Hello guys and welcome. In this video I'm going to show you why and how Honda HET works. So for those who are not from India, Honda HET is a technology which is implemented in all scooters and motorcycles of Honda since 2013, and the main aim of this technology is to provide the same torque and power but to increase fuel efficiency. This technology actually revolves around the three core concepts, which is reducing the friction inside the engine, improving combustion efficiency, and to cope these two things up, optimizing the gearing and CVT pulleys. So how all these things work, let's find out. First comes is reducing the friction. Honda reduced the friction inside the engine by offsetting the crank inside the engine. So how does offsetting a crank improve fuel efficiency? This is a conventional engine. When the piston goes down in the power stroke, what happens is there is too much of friction on one end of the connecting rod and this side of the piston, assuming it rotates in a clockwise direction. In offset crank, what happens is instead of keeping the piston cylinder and crank on the same axis like in conventional engine, the piston and crank are just a little bit offset from the axis of crank. This helps in reducing the friction on this end of the connecting rod and this side of the piston and cylinder. The best example to explain this is like say you're cycling on a plain ground and you encounter a slope. What would you do to get more torque? Obviously you would stand up and start pedaling. Standing up on the pedal applies more torque on the pedal. The exact same situation happens here. So using only muscle needs more effort and provides less torque, but pedaling while standing needs less effort and provides more torque. This design of an engine is not a foolproof design. Why? Because uneven wear and tear happens on the piston rings and cylinder sleeve. Because when the crank is at this point, it tries to push the connecting rod in this direction, but due to cylinder wall, what happens is piston moves up, so this causes more friction at this part and less on this one. Next comes is the vibration, smoothness and noise. Don't mind the spelling, I know it is wrong. Anyways, say you have a block of mass M oscillating vertically. To roll out these vibrations inside any system, what would you do is to oscillate another block of the same mass but in opposite directions. So the net resultant would be 0. But in conventional engines, it is easier to rule out the vibrations. But in offset crank engines, it is pretty difficult because you can't just increase the number of components inside the engine, so you have to balance it out in the same number of components. Another factor is the mass of components oscillating inside the engine. Higher the mass, higher the vibrations, so Honda reduced the mass of all these parts. Next up comes is low tension piston rings. So to understand the low tension piston rings, we first have to understand what are actually piston rings. As the name suggests, these are just rings, but these are not complete rings. They have some space between two ends. Say this is a cylinder and I want to fit piston rings inside this. So what we do is we first compress the piston ring, push it inside the cylinder and release them. So it applies some force on the cylinder walls. That is what is called as tension. And obviously higher the tension, greater the friction, lesser the tension, lesser the friction. These are the piston rings and this one is backed with springs just to push this ring onto the cylinder wall. This is the oil ring which scrapes off the excess oil from cylinders. This is the combustion ring which seals the combustion chamber, and this is the intermediate ring which does the job of both worlds. But even this is not a perfect design because it causes a phenomena called as blow-by. As you can see in this rough sketch of an engine, combustion is taking place obviously on top of the piston and the bottom are the oil vapors. Due to less tension here, the sealing is not very tight. So a few particles of oil make their way in the combustion chamber and are combusted, and vice versa. This causes increased oil consumption and oil contamination. Using low tension piston rings causes frequent oil changes but fairly less friction. Also, another thing comes is the design of bearing oil seal. As the combustion happening at top of the piston is at thousands of psi, so the pressure making its way to the crankcase needs to be controlled to prevent oil leaks. What Honda did to prevent oil leaks is they redesigned the bearing oil seal. They made it stronger and smaller. Smaller the oil seal, the less impact of pressure it will have, and vice versa, as the formula for pressure goes as P is equals to force upon area. Next up comes is optimizing combustion. To optimize combustion, they redesigned the combustion chamber and used a nickel alloy spark plug. Using this quite complicated name is also a marketing gimmick. There is nothing special about nickel alloy spark plugs, as most of the spark plugs are made from nickel alloy. Conventional spark plugs have some sort of rounded edges. On using the spark plug, what happens is erosion happens at the edges of spark plug, which makes them round. In Honda's engine, the composition of the alloy is a little bit different. Using the different composition of the alloy, it makes the spark plug harder and stronger. How does this help in improving combustion? So what happens is, on a spear, if you charge a spear, charges will evenly distribute on all directions. But in anything other than spear, which has a sharp edges, what will happen is the distance of the outermost point is the only point where the charges can escape, resulting in more powerful spark. That is the reason these days the platinum iridium spark plugs and all those type of high performance spark plugs come in this sort of triangular electrode layout. Another thing to improve combustion efficiency is redesigning the inlet port. As we know, the heat triangle comprises of three things, which is oxygen, temperature and fuel. The temperature comes from spark plug, but oxygen and fuel needs to be thoroughly mixed. Why? For example, take a tube and concentrate fuel at one end and concentrate air at the other and ignite the mixture. It will not be a complete combustion because this side of the tube is richer and this side is leaner in terms of fuel. As after the combustion, there still would be a few particles of fuel left here and many particles of air left here. So a good and even mixture of fuel like this one provides complete combustion. The inlet port was redesigned keeping these things in mind. There are two things happening inside the engine. One is swirl, another one is tumble. In swirl flow, as soon as the intake valve opens and vacuum is created inside the combustion chamber, the path of air-fuel mixture or charge is just like a spiral or a spring. And in a tumble flow, as soon as the vacuum is created inside the combustion chamber and intake valve opens, the path of the charge is like a spiral. The only difference between both things is inside the combustion chamber, this path is like this and this one is like this. Gives a nice even air fuel mixture that helps in good combustion. The last thing comes is optimizing the ratio of CVT pulleys. Earlier the engine was producing low torque and giving low mileage, but now the engine has high torque. How to convert that torque to maintain fuel efficiency? But now the engine produces much higher torque, which is not really needed as no one pulls a giant trailer behind their two-wheeler. So how to convert that high torque into fuel efficiency? For that to happen, we first understand how torque is converted to power and how power is converted to torque. So in this sketch here, these are the primary pulleys and these two are the secondary pulleys. As you can see the visible difference. In first case, the primary pulley is smaller than the secondary and vice versa in the second one. If I rotate this pulley one time, this will definitely rotate more than one depending on the radius, and the ratio of that radius is called as gear ratio. So how is it possible that I make this pulley rotate one round but this had more rounds, as energy is never created nor destroyed, energy is conserved, right? So what actually happened here is I had to put more efforts on rotating a big one and that is why the smaller one rotated more number of times but with less torque, and vice versa in this case. It is actually the same case like tightening a nut or bolt with a hand and with a screwdriver, keeping the factors like grip, strength, etc. aside. So this is how Honda optimized the CVT pulley ratio by making the driving shaft bigger as it has more torque than earlier, and keeping the driven pulley same but provide same sort of performance on driven pulley. Now I'm sure that you have a basic idea of how Honda Eco Technology or Honda HET works. Now only two things are remaining. Subscribe and share this video, and for any questions or comments, feel free to leave them below. I would love to answer your questions. See you in my next video.